we're wrapping up Chapter 1, Section 2, Graphs and Lines in Barnett, and the last goal here is to solve applications of linear equations, and we're going to look at two of those applications. For the first one is depreciation, and here's what happens with depreciation. We have office equipment that was purchased for $20,000, and it says that it will have a scrap value of $2,000 after 10 years. Okay, well, if its value is depreciated linearly, find the linear equation that relates value, V, in dollars, to time t in years. So what happens is, every time you buy any type of a good, like a brand new car or office equipment or lawn and garden equipment, anything of that type, its value depreciates over time. You've probably all heard the expression that the moment you buy a brand new car, the second its wheels cross the dealership's exit, then it already depreciated in value. Well, that's exactly what this means, that the original value of this equipment was $20,000, but because the value goes down in time, after 10 years, it's only worth $2,000. Okay, and we are told that this is depreciating linearly. This is the key to the problem. If it's depreciating linearly, we could assume a linear relationship. So how can we find a linear equation? Well, just like before, we need a slope and a y-intercept to do so. So to calculate the slope, notice that we could come up with 2 points, two ordered pairs based on the given. And the first one is going to be 0, 20,000. The second one will be 10, 2,000. These are points of the type t, comma, v. In other words, the time t is presented first in the order pair, and then the value of the equipment comes second. So I have t, comma, v. When time is 0, in other words, when you purchase the equipment, when it's brand new, it's worth 20,000. 10 years later, it's worth 2,000. I could use that to calculate the slope of this model. So the slope would be 20,000 minus 2,000. The difference is in v, divided by 0 minus 10, the difference in t. Think of this, if you want, as t1, comma, rather t2, comma, v2, and t1, comma, v1, right? And we have v2 minus v1 over t2 minus t1 as a formula for slope. That gives us 18,000 divided by negative 10, or negative 1,800. Okay, and if you think about a second about the slope, what it really means is that every year the value of that office equipment is depreciating by $1,800. That's what this negative slope, negative rate is telling us, right? You can think of the slope as a rate of change, if you remember. Okay, well, with that in mind, we're almost done with our equation. The next thing we need is a y-intercept, but we know the y-intercept. That's 0, 20,000, right? The y-intercept is the value that you obtain when the input, the x, is 0. Well, we don't have x's and y's, we have t's and v's here. So when t is 0, v is 20,000. That means that our model is v equals negative 1,800 plus 20,000. Okay, and this should be negative 1,800 t plus 20,000. Okay, so based on this, plug in any value of t, and we will obtain what the office equipment is worth at that time period. Alright, and one other application we are to look at here is supply and demand. So in a free competitive market, the price of a product is usually determined by the relationship between supply and demand. The price tends to stabilize at the point of intersection of the demand and supply equations. Well, the point of intersection is what we call the equilibrium point. Okay, and I'm sure you guys read in your text about supply and demand and about the equilibrium point. So obviously, when at the equilibrium point, the corresponding price is what we call the equilibrium price. Alright, and the common value of supply and demand is called the equilibrium quantity. So there's 3 vocab terms there that will be applying here. So let's look at an example for supply and demand. Use the barley market data that was given in your textbook, and it's presented here in the following table to find 3 things. We want a linear supply equation of the form P equals mx plus b. We want a linear demand equation of the form P equals mx plus b, and we want the equilibrium point. So once again, you would use the fact that these are going to be linear equations in order to come up with them. So for each supply and demand, we have some data in our chart here for 2002 and 2003. And to find the supply equation, let's start with part A. For the supply equation, we want the form P equals mx plus b. We must first find 2 points of the form x comma p on the supply line. Once again, in order to find a linear equation, you need a slope and a point, right? So that's why we need 2 points of this form, x comma p. Well, from our table, we could see that when our supply is 340, our price is 2.22. Therefore, we have the ordered pair 340, 2.22. Likewise, we have 370, 2.72, because when supply in 2003 was 370, the price was 2.72. Okay, so, oops, sorry about that. So these are 2 such points. We use those 2 points to come up with a slope. So maybe call this x1, p1, and x2, p2. And we have p2 minus p1, 2.72 minus 2.22, divided by x2 minus x1, 370 minus 340. That gives us our slope of 0.5 over 30, which is about 0.0167. Okay, what do we do with that? Well, we go ahead and we use the point slope form to find the equation of the line. Okay, so we use point slope, which is p minus p1 equals m times x minus x1. This has been done for you here. And all we do is we plug in using x1, p1 to be the point 340, 2.22 again. And our m is 0.0167, which we found earlier. So we plug in the appropriate values, and we get the price supply equation as 0.0167x minus 3.458. Well, we get to repeat the same exact process for the price demand equation. It's just that now when we look at our chart, we're going to be looking at the demand values and the corresponding price. So we're now looking at ordered pairs of the form D, P. D, P. Okay, let's call it D just to differentiate it. And once again, we get 270, 2.22. Here's the first one. 250, 2.72, the second one. And we use that to find the slope to be negative 0.025. And you could pause the video here if you'd like to see the rest of the problem. It's just setting up the point slope form and solving for P, right, which is our price demand equation. And that's also a linear equation. Okay, and the last part, part C, was to graph the 2 equations and find their intersection, right? They wanted the point of equilibrium. Well, in order to do that, all we have to do is use our calculator, right? We could just input the 2 equations on our calculator and find the intersection using the intersect method. And that's going to give us 298, 1.52. So what that means is that the common value of supply and demand is 298 million bushels when the price is $1.52. The second coordinate, the y coordinate here, represents price. The first coordinate represents the amount of bushels that we need. So that's what's happening in this problem.